Hello guys, welcome to my YouTube channel. Myself Kirtan. Today I am going to discuss about exponential distribution and its applications. Let's see the outlook. First we're gonna see introduction of the exponential distribution and probability density functions. Next cumulative distribution functions and difference between probability density function and cumulative distribution functions. And last we're gonna see applications of exponential distribution. First we're gonna see introduction. The exponential distribution is a probability distribution that describes the time between event in a Poisson process where the event occur continuously and independently at a constant rate. The exponential distribution is a technique which we going to use to see the uh, expiration of the product when it's going to end or it's going to expires in a particular time. It is commonly used in reliability analysis, queuing theory, and other fields where the occurrence of events is random and continuous. The exponential distribution technique is used in the random occurring events like reliability analysis and queuing theory and some other processes. Next, we're gonna see probability density function. In probability theory, a probability density function is used to define the random variables probability coming within a distinct range of values as opposed to taking on an one value. In probability density function, it not going to take a chosen value. It going to choose a value as randomly and going to use it. The probability density functions of the exponential distribution is given by f of x lambda equal to lambda e power minus lambda x, whereas x is greater than or equal to 0. This is the equation of probability density functions, where lambda is a rate parameter which determines the average number of events that occur per unit time. Lambda determines the how many number of events going to occur per unit time. The PDF is always positive and it approaches 0 as x approaches infinity. Probability density function value will be always positive and it approaches 0 as x approaches infinity, as the line of probability density will be going on until infinity. As we can see in this graph, the probability density, the value x value is going to be extending from to the infinity. Next we're gonna see cumulative distribution functions. In probability and statistics, the cumulative distribution functions CDF is a real valued random variable says x, which is evaluated at x is the probability that x takes a value lesser than or equal to the x. In cumulative distribution function, we take the value x, which will be equal to 0 or less than 0. Means we're gonna get the value as negative value because the x value will be lesser than 0. The cumulative distribution functions of exponential distribution is given by f of x lambda equal to 1 minus e power minus lambda x, where x is greater than or equal to 0. This is the equation for the cumulative distribution functions, where f of x lambda is the probability that an event occur within x unit of time. The CDF is always increasing and it approaches on as x approaches infinity. The CDF value will be always increasing, as we gonna see in this graph. The values, the graph lines are going up and been continuing until the infinity. Next we're gonna see difference between PDF and CDF. PDF means probability density function, CDF cumulative distribution functions. The PDF is a function that describes the probability distribution of a continuous random variable. The PDF will take the value as random and will be executing the random values, and it will not take the value which has been given. The CDF is a function that give the cumulative probability that a random variable x will take on a value lesser than or equal to a given value. As we know that CDF will take the value which is equal to or lesser than the zero value. The mathematical term for the continuous random variable x, the PDF is denoted as f of small letter f of x and is defined as the derivative of the CDF with respect to x. The mathematical term of the PDF is given as small letter f of x, and PDF is the derivative of the CDF. In CDF, the mathematical terms for a random variable x, the CDF is denoted by capital letter f of x. In CDF, it is derived as the capital letter f of x, and in PDF it is derived as the small letter f of x. And in CDF it's defined as the integral of PDF from the negative infinity to x for continuous distribution. The total area under PDF curve over the entire range of the random variable is equal to 1. As we know that PDF value will be 1, and it covers the entire range of the positive values and curves. The CDF starts at 0 for x to infinity and increases monotonically up to 1 for x is equal to plus infinity. As we know that the CDF value will start from minus infinity and it will be continuing in the plus infinity as it covers the full ratio. Next we're gonna see applications of exponential distribution. First application for exponential distribution is reliability engineering and failure analysis. The exponential distribution is widely used to model the time until failures of system or components with a constant failure rate. It helps in assessing the reliability and estimating the mean time to failure, MTTF. MTTF means mean time to failure to products and systems. Reliability engineering and failure analysis, we're going to use exponential distribution in this to calculate the uh, failure of the components which has been produced, or the how many days it gonna extend. We're gonna calculate the time of the components. Radioactive decay, the exponential distribution is used to describe the time it takes for a given quantity of radioactive substance to decay. In radioactive, the exponential distribution is used to calculate the decaying time of the given radioactive elements. It is used in like nuclear reactors and nuclear bomb preparing areas to calculate how much time it takes to deactivate the radio particles. The decay process follows a constant rate, and the exponential distribution helps predict the probability of decay within a certain time frame. Probability exponential distribution gives the time which when the radioactive will going to decay completely. Next, we have internal traffic and packet arrival. The exponential distribution is used to model the arrival time of the packets on messages in computer network and the internet. This helps in understanding network traffic pattern and optimize data transfer. In internet trafficking, the exponential distribution is used to how much time it will take when there is a server jam or many user accessing the same internet. It gives the time when the internet going to access the how much time it will take to download the particular websites and particular downloading applications, how much time it will take to download. In packet arrivals, like in Amazon, it will give some time to arrive the packets due to shipping depending on your address. It will calculate how much time it will take to reach the packet to your address. Random number generation. The exponential distribution is one of the distribution used in generating random numbers for various simulation and modeling purposes. Uh, in exponential distribution, it will give the random numbers, various simulations and modeling purposes. And last, thank you for watching my video.